Thank you, everybody, for joining us back here at Nubeva's channel. We're sitting here once again with Randy, and today we wanted to go over Q1 just a little bit with you guys, but more importantly, dive into the exciting world of patents with Nubeva. Randy, how are you doing? Are you ready to get into it?
Excellent. Absolutely. We get a little bit of a heat wave this week, but other than that, absolutely, it's great.
Yeah, wonderful. Here in Ohio, we're finally actually getting rain, and we had a burn ban for a while, so glad to finally get it at least at the end of the season. But
Good.
Randy, kind of getting into it a little bit, we want to just
Yeah,
touch lightly on Q1. So what are the updates?
sure. The update is essentially the same. I've mentioned this before. We are managing cache very, very carefully. What we're trying to build out right now is build an IP that we can go out and use and leverage that, whether that's through an M&A, whether that's through an asset sale later on. What we're trying to do is to make sure we're very responsible with cache. And as everybody's going to be able to see, the cache is exactly how I described it last time around. We're maintaining cash flow positive or near positive, depending on when our payments are due, et cetera, et cetera. But this is something that we can have indefinite, from an indefinite basis standpoint, maintain this.
Wonderful. So long story short, steady as she goes. This is exactly where you
Exactly.
expected to be.
Exactly.
Perfect. Okay, so kind of diving into the more exciting topic, talk to me about these patents you guys got going on right now.
Yeah. So as I mentioned, the key part of us building IP, obviously creating software and services that our customers want. And I've mentioned the deployment of one of the largest financial institutions is going very well, along with many other ones that we've had before. Everything that we do right now from a software standpoint is going well. We're automating everything, the support structure, the QA structure, and everything else. And even some parts of development is all AI driven. But obviously, we have to build out the IP associated with that. So we've actually filed 4 patents this quarter inside AI with ransomware. Um, the 4 of them, the first one is actually something that we had filed before, but one of the things that a lot of the patent officers will do and agents will do is file a patent and continue it with all the future patents. And what that does is your first patent, each patent has a deadline of 20 years. So in other words, you can monetize on it exclusively for 20 years. And after that, you're supposed to share them. So what a lot of the more experienced patent agents will do is they'll say, okay, this new one is a continuation of the last one, and the next one is a continuation. And so what that allows you to do is if you keep filing them, well, you can argue that the first one should be continued well past that 20 years. Now, obviously, at some point, we did a TLS asset sale, and so we needed to decouple that. And that was actually very simple. So one of the patents that we actually went out is that we decouple from all the previous patents that we had to do. Now, that doesn't mean it actually delays the filing or anything to that effect, but we had to decouple it so it's brand new and it's the basis for all the other patents that we actually submitted is intelligently recovering from ransomware attacks. As I've talked before, let's say you're a reasonably large enterprise, not even S&P 500, outside of the S&P 500. It's not unusual to have 30,000 to 50,000 machines that one has to recover at any given time after a ransomware attack. And so you can imagine, well, each one of them, you have to wipe everything out, install the entire operating system, all the software, how people wanted to run it, and then put the data that the users were using in a usable state. And so the AI that we're developing here is how do you speed that up? I've talked about this. The greatest inhibitor of our expansion is actually not opportunity right now. It's the fact that if we sold our product to someone who got a ransomware attack, how do you recover them? What are the emergency services associated with that? And so this is the critical first step from an IP standpoint. We're filing a patent to allow people to, with very little headcount, be able to recover massive amounts of machines that have been ransomed. So that's the first one. The next one is the ability to use, and just like with everybody else, it is using AI to find when something's actually been encrypted. And so we don't call it AI in this case because we've realized that just like everybody else, I think the patent reviewers are getting tired of reading something that's related to AI. So we call that computational intelligence, just like Apple went out and call it Apple intelligence. But at the end of the day, detecting when something's been encrypted is very critical. I think I've mentioned a story where somebody's lab, when they realized they were ransomed, and the IR people went in to look at it, it turned out the lab machine had been ransomed twice. So the first threat actor went in, displayed, say, hey, pay this amount of money. Well, nobody's looking at the console of the VGI port, whatever you want to call it these days, was not even hooked in. And so the end user didn't know they were ransomed. The machine was still running just fine. So this is a failure on the ransomware, obviously. And the second ransomware comes in and it encrypts it and then does do damage. And we go in and look at it. It goes, well, we can recover the thing that the second one did, but the first one had been done so far long ago that you can't do anything about it. And so you're going to see the trend of our IP where we're not only using it to find keys and find an efficient way to recover it, but really when the machine is actually being ransomed, we actually go out and do things to make sure that we understand here's the checkpoint of this is what started, this is what's happening, this is what's going on. And quite a few ransomwares out there today don't encrypt the whole machine. They'll actually find portions of the file to encrypt. And so they're harder to detect, harder to recover. But at the same time, a lot of times they don't get paid because they didn't actually encrypt what really matters. So.
Interesting. So it's kind of like an arms race then at this point. And this is the next step you guys are taking to kind of, get a step ahead for now, right?
Exactly. And this is a little bit kind of a sideways conversation. I've been talking in Silicon Valley with a lot of people, and we've been seeing a trend that I'm sure I'm sure it's discussed on the internet. We are beginning to see a massive amount of software deployed compared to before, where you have companies that really had never had any software engineering hire 5 or 10 software engineers and go out and use AI, based on AI, create a lot of software that helps them become more efficient. I think one of the things that we saw during COVID is you go into a restaurant and you get this QR code and you start ordering food and then you pay with it. And that's kind of quite desirable. Well, so we're seeing a balloon of software out there. So unfortunately for that, just like with my car, the full self-driving on my car, when you add that substantial amount of software, there's quite a bit of it that's not very good. And so when you don't have very good software, the attack vectors from the threat actors just keeps shooting up. And so the amount of manpower that one can put out there to just manually go restore a computer that's been ransomed, that's just going to end. We're just not going to get there. Something has to be automated where we can automate. And so you got the threat actors on and trying to automate a whole bunch of things against a whole bunch of software that's automated when it was created. And clearly the solution has to be automated too. Yeah. So hopefully that's kind of obvious nowadays. If it's not, you will buy it by next year. This is kind of like at the beginning of the internet, every software that anybody created would log things, right? Would say, hey, your machine is up, your machine went down, your internet went up, your network went down. And so these are called machine generated logs. They're not human generated logs. And so as that grew and grew and grew, you started creating a massive business, an $80 billion business of machine generated logs processing. So nothing else. There's an entire business in computers, in computer networking, just to process the logs that are generated by machines. And so that's a very small, I guess this is the closest analogy I have to what's happening with AI. That's got to be tiny compared to the sheer amount of software that we're going to start seeing AI start generating software. So that's just going to massively balloon. So.
Interesting. So there's going to be tons of low-hanging fruit and generated more
Yes.
and more every year. And the
Yes.
threat actors are obviously automating everything. Everything's automated. The solution has to be automated. There's no way around it.
Right. Exactly. Yep.
Perfect. All right, Randy. So
Yep.
there's a couple more, correct?
Yes. And the third one is actually detecting when an encryption is actually happening. And that's kind of 2 and 3 sound a little bit somewhat similar, but the third one is actually much more critical. And that leads to the fourth one. What threat actors are starting to realize is they're actually encrypting. The larger a file or data is, the more obviously you encrypt somebody's database that they're using for billing, et cetera, or services. The more likely a threat actor is going to get paid. So the larger the files that are actively used, the more likely if you create damage to that, you're going to get paid. But at the same time, if you create too much damage, people are going to find out that you created damage. You're going to get caught. And so finding where to encrypt inside a massive large database that is of high value but hard to detect is very critical. All right, so then, that's from the threat actor perspective. From our perspective, then obviously is as we're getting keys, and this is our core IP is essentially giving AI a set of tools, a weapon to go out and put in the AI's arsenal to mix together and say, wait a minute, this database should not get encrypted at this time, right? This wouldn't make sense. You encrypt when you get in, you encrypt when you back up, but 3 a.m. on a Saturday night, that's not normally when you encrypt. Okay. So coming back to what we would do is, well, we detect when encryption is happening, when keys are generated. And so the detection of the accuracy of this is being encrypted, this is the wrong time to do the encryption. This portion of a massive file is the wrong piece to be encrypting. That's what we're actually trying to start. That's what this AI actually covers.
Interesting. Interesting. So, and you said that kind of leads into the fourth one as well.
Exactly. Yeah. So the fourth one is something that we have had quite a bit of experience. I think I've talked about, people have asked, where do ransomware attacks happen? By and large, mostly inside Microsoft Windows and Windows servers. Okay. But there's probably, I'd say 20 to 30% growing very fast that is actually on Linux. So people would have thought it's on OS X or something like that, or Chrome, etc. No, it's actually on Linux holding very large virtual disks. So if you're running VMware or Hyper-V, typically you're going to have a massive VMDK or virtual disk out there. And so what threat actors will do is say, I'll encrypt for every 10K bytes inside a file, I encrypt 1K. Another 10K, I encrypt 1K. And I think we had a little bit of discussion of how we then helped one of a very large enterprise in the food industry that had files encrypted. And so we were covering that. In fact, they had two ransomwares hitting the same file at the same time. That's how large these files are, how slow they take to actually go out and encrypt. And so what we go out to do with AI now is what we used to do manually. Saying, okay, this portion was encrypted by 2 keys, this was by 1 key, et cetera, et cetera. And most of the time, the math is fairly simple. I think it's if you go back to high school algebra, XORs are associative. So that means we don't actually have to figure out was this the second key or the first key that encrypted this file. So any order will do most of the time in that case. And so it's understanding this portion of the file was encrypted by this 1 key versus 2 key. We used to have to do this kind of massively brute force. So you get, literally hundreds of thousands of keys, and you get tens of thousands of VMDKs, and then let's match up, right? This is kind of like who's going with whom to the dance kind of a thing. And so now it's different. We're essentially using AI while it's getting encrypted. We generated the keys, and you can ask, well, if you know that it's getting encrypted, why don't you stop it? We're working on that. That's something that's very critical. That being able to stop it would be better. But at the same time, if we're gonna stop something like that, we better be right. So you can't have false positives of that. So this patent that we filed is about very large files being encrypted, sections and sections of it being encrypted, and figure out what key belongs to which from a decryption process sample. And decrypting it itself is very important. Most of the time, when it relates to these types of files, we have to decrypt in place. Now, the customer will do their backups into the cloud, et cetera, but they don't have a staging area that says, well, here's 50 terabytes of 10,000 files added up to 50 or 100 terabytes. Here's another 100 terabytes and put it over there when you're done, right? They might have a spare 10 terabytes at best sitting around, and you got to decrypt it right there. Otherwise, you got to move it out and move it back in, and that can be, you might as well just get a truck and do that using, Amazon has a service to move massive amounts of data using a truck. So, and no customer wants that because that takes forever to recover. They also don't want their data to be removed out of their premises for obvious reasons. So,
You're kind of patching the boat while it's still sailing down the.
yes, that's a great analogy, actually. I wonder if AI is going to fix that one day.
Yeah, it might.
Hold your boat. Here's a little robot that went out and fixed it for you. Well, you just got to slow down by 20 nautical miles or something.
Yeah, well, I mean, it's already doing just about everything else, and
Right.
the patents and the IP, Nubeva has been growing and everything really
Right.
does paint a picture of an accelerating intelligence kind of playing here. And if you were to look back a year ago, Randy, would you say that back then you were accurate in your assumptions of where we would be today in terms of where the threat actors are now and where the technology is?
I think I don't want to take too much uh, of how accurate we are or not. I think a lot of people kind of, once you pointed out ChatGPT to me, not shortly after that, people started thinking this is where it's going to go, and these are all the good things that's going to happen, and we're seeing it, and these are the potentially bad things that are happening, and it is indeed happening. So I don't know that was that hard to predict, but yes, absolutely, we are embarking in a path that I think a lot of people called when they saw AI coming. I think the thing that scares me a little bit, it's actually happening faster, which happens a lot inside our industry. It's actually happening much faster than I could even imagine, right? So when you told me about ChatGPT, I told everybody else. And soon thereafter, I mean, there's just not a single person that I know that doesn't use it, or I guess there's a percentage of people that doesn't pay OpenAI for it. They get this free one, and I certainly pay for it, but it's just going much faster than anybody predicted. So it's
Yeah.
it's absolutely staggering. So
Wonderful, Randy. Well, listen, thank you for coming on and sharing the updates on the patents and everything. If anyone has any questions, don't be afraid to send them over. Randy, do you have any closing words?
no, that's it. Thank you very much.
Perfect. Thank you for your time, Randy, and thank you everyone for watching.